What's good, YouTube? We got Cam, not a science guy.
It looks like there's a terrifying crack in our understanding of the universe. Scientists have compared how fast the universe expands. Two methods, two measurements, completely different answers, and no one knows why. As they dive deeper into this, a new terrifying idea came up. Our entire universe might be spinning. If that's true, it changes everything we know about space, time, and even how the world will end. To understand what's going on, let's talk about how our universe expands. How exactly is it expanding? Into what? We first noticed this about 100 years ago. For many years, people thought the universe was eternal and unchanging. Then came Edwin Hubble. He observed the universe in the telescope and realized the light that came to our planet was coming from galaxies that were moving farther away from us. The galaxies weren't sitting still. The whole universe was moving. And this became one of the most revolutionary discoveries in history. The movement started with the Big Bang. It happened about 13.8 billion years ago. The entire universe, all matter, energy, space, and time burst forth from an incredibly hot...
The Big Bang really happened? That's crazy.
Dense point. The bang sent a shockwave, giving all the things and particles their initial boost. That's how they started drifting away from each other. The thing is, they weren't drifting away into open space. No, they created space themselves by drifting. Let's say you're holding a balloon. You draw some dots on it. You start blowing air into it. The balloon gets bigger and bigger. And every dot on its surface moves away from every other dot as the balloon expands. As dots move apart, they basically create space between them by moving away from each other. So the universe isn't expanding into some mysterious space. Space itself exists only within our universe, born between moving dots. The Big Bang boost was so strong that the universe started expanding incredibly fast. It's hard to even imagine. If you were chilling and watching this from the side, it would seem like the entire universe appeared out of nowhere in less than a moment. You wouldn't even hear it because there's no sound in vacuum. There would be nothing. Then you would just blink and bam, the world is everywhere. That bang was so huge that the universe is still expanding from it even now. Even billions of years later, it's space itself that's stretching. With every...
Chat. Y'all feel like it's aliens out there? I believe in aliens, because I feel like if it's us, it's somebody else out there. Gotta be. You got... Look at the sea animals. I ain't gonna lie. See, when you really dig deep into, like, all the sea animals, shit is crazy, bro. It should have kind of spooked you out a little bit. And then you got, like... World is just too big. If it's all these different planets, can't just be us. It gotta be somebody else out there. Gotta be.
Point on it drifting farther and farther away, including us. We're just moving at a more gentle pace, sort of. So when we figured out everything was expanding, the next question was, how fast? Turns out the movement speed is different for different galaxies. We noticed that the closer things are to us, the slower they drift away from us. And the farther a galaxy is from us, the faster it appears to be moving away. And they're moving constantly. We say, for example, this galaxy is 100 megaparsecs away. But since the galaxies don't actually stay in one place, that means this galaxy is moving at a speed about 4,300 miles per second away from us. If the distance doubles, then the galaxy's speed doubles. So, for example, if a galaxy is 1,000,000 light years away, it will move away from us at a speed of about 46,000 miles per hour. 2 million light years away? Double it. Now it's about 92,000 miles per hour. 10 million light years away? Almost 500,000 miles per hour. Scientists call it Hubble's law. Speed is equal to Hubble constant multiplied by distance. And the Hubble constant is the exact magical speed number that we keep adding up every time we move a million light years farther. So, the Hubble constant is basically the rate at which expansion happens. But there was a problem. A problem that seemed tiny at first, but it was actually hiding a huge disaster. When we measured Hubble constant using two different methods, for some reason, we got different results. The first method was to calculate it based on what we see around us right now, today. Different stars, galaxies, their light and brightness. In certain stars, brightness changes in predictable ways. Huge star booms, like supernovas, act like cosmic lighthouses. We know how bright they should be, and thanks to that, we can calculate their distance and speed. It's all clear and simple. But then, scientists tried something totally different. They often used this trick. To figure out how the early universe behaved and then simulate everything from the start, it's like creating your basic characters in Sims and letting them do whatever, hoping that they'll do things in predictable ways and not pull off something wild. We can guess what the early universe looked like because we can still detect the faint afterglow of the Big Bang. We have ultra-precise telescopes that allow us to find an ancient, very first light and very first traces of energy that were born in our world. This post-Big Bang afterglow is literally filling up the entire universe. It's just scattered around like some dinosaur fossils. So we take these fossils and recreate the entire dinosaur based on them. And when we measured what the Hubble constant should logically be, based on how our universe was starting, we got a different number. It doesn't sound like a big deal at first. Based on what we see today, every 3 million light years away, things are moving about 40 miles per second faster. But based on how our universe was supposed to develop, the number is about 45 miles per second.
Damn.
Literally just 4 miles or so, right? But in cosmology, it's an ultimate red flag. The error bars have shrunk so much that now this isn't just a meh, probably fine situation. It's a literal tension in measurement. And that's exactly what scientists call it, the Hubble tension. It's a serious difference between two super precise measurements based on very different methods, and both of them seem equally right. Imagine using two ultra-precise clocks to check how fast an athlete runs a distance. And in the end, one of the clocks says 10 seconds, while the other says 11. What in the world does that mean? That's terrifying. The two numbers should match, and since they don't, one of three things must be true. First, maybe one of the measurements is wrong, which is very unlikely because both methods are super reliable. Second, maybe something in our interpretation is wrong, but that's also unlikely since many scientists get the same results and agree that the tension is a real deal. And finally, the scariest option, our entire model of the universe is missing something. That's why scientists are freaking out, and as it turns out, they had a reason to. Recently, a new research team from Hawaii proposed something wild. What if the universe is very slowly rotating? If that's the case, it would be absolutely insane. Here's why. First, if the universe actually rotates, even super slowly, it would mean that the laws of physics might be slightly different depending on where you are or which way you look. That breaks one of our most sacred ideas about physics, that space is the same in all directions. Second, it could mean we've misunderstood the entire cosmic history. Maybe we don't actually know how fast the universe is expanding when it was born, or what dark energy is. That would be a huge disaster. And finally, the most horrifying of all, if it's spinning, then it must spin around something, right?
Yeah.
If there's a cosmic axis or rotation, it might suggest a preferred direction. It would be something like cosmic north. We thought there's no special place in the universe, but we might have been wrong. Maybe there's a special place after all. It's like finding out the reality itself has been tilted a tiny bit the whole time, and we just noticed. Right now, we're in an exciting and scary place. Either we'll discover new physics and maybe something about dark energy, or we'll find a subtle error in one of the measurements. Or who knows, maybe something totally unexpected will show up. In any case, solving the Hubble tension could revolutionize our understanding of the universe's origin, structure, and our place in it.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.
Well, chat, we learned that Earth is fucked up. Space is fucked up, my bad. I'm fucked up. Kids don't get fucked up. See y'all on the next video.